This will be the second part of my Pythagorean theorem video. In the first one, we talked about calculating the length of a missing side of a right triangle. This one, our learning targets will be to determine whether a triangle is a right triangle or not. So we'll be given three side lengths, and you have to figure out, is it a right triangle or not? And the next part is we're going to determine whether three numbers are a Pythagorean triple or not. So you ask, well, what's a Pythagorean triple? Very good question. That's our little vocab word for this lesson. A Pythagorean triple, I look at it as there's two parts to it. It has to satisfy two things. Triple, 3, so we're going to have three numbers. Now, those three numbers have to be whole numbers. So if you have three whole numbers, you're on track to being a Pythagorean triple. Now, the second part of it is those three numbers have to make this little equation true, what most of us know as the Pythagorean theorem. So if we have three numbers that when we put them into this equation, it comes out to be true, Pythagorean triple. One little example would be 3, 4, 5. Sometimes people think of it as one of the most famous right triangles out there is the 3, 4, 5 right triangle. Now, there are many, many more of them. I pose the question, can you find examples of more Pythagorean triples? I'm going to leave that one up to you. Now, this is the corollary or the converse to the Pythagorean theorem, and it just goes the other direction. What we learned before was if it is a right triangle, then essentially a squared plus b squared equals c squared works. This, we flip it around. So if you look at the wordiness of it, it says if the sum of the squares of the measures of two sides of a triangle equals the square of the measure of the longest side, then the triangle is a right triangle. Again, I look at that as extremely wordy, and here's really what it's saying. It's saying this. If you have three numbers that will make that equation true, then we can take those three numbers, the a, the b, and the c, put them onto a right triangle, and it will make a right triangle. Now, here's the kicker. You have to make sure, though, that the c is the biggest one. As long as c is the biggest one and it makes that true, well, the biggest side in a right triangle is the hypotenuse. The a and the b, those can be switched around because those are the two legs, but the c has to be the biggest one. So if you get three numbers that make that little equation true, it will make a right triangle. So I have an example here. I give you three sides of a triangle, 21 inches, 35 inches, and 28 inches. And I have two questions. Will those three sides make a right triangle? And then, are those three sides a Pythagorean triple? So, in order to see if this is going to make a right triangle, I just use the Pythagorean theorem, or what most people think of it as a squared plus b squared equals c squared. And I put those numbers in. Now, I'm going to write this down first. Remember, c always has to be the biggest one. So I look in here and I go, that's the biggest side, or the largest side. That number has to go in for c. I put 35 right here. Pythagorean theorem says we have to square it. And then the 21 and the 28 don't really matter where they go. I usually like to just put them in numerical order, and then I know I'll always have c being the largest side. So I'm going to have 21 squared plus, and then 28 squared. Now it's just a matter of seeing, is this true or is it false? So I look at it and I go, well, 21 squared comes out to 441, plus I have to add on 28 squared, which is 784. When I add these two numbers together, it comes out to be 1,225. Well, if I square 35, that is also 1,225, which means, yes, we have a right triangle. So to answer my first question, do the following side lengths make a right triangle? Yes. So it's going to go like this. Yes, it's a right. I'm going to abbreviate triangle with the little symbol. Now, the second part, though, that I have there in green are the numbers of Pythagorean triple. Well, this is where we have to go back to what is a Pythagorean triple. And a Pythagorean triple, remember, is three whole numbers. Well, 21, 35, and 28 are whole numbers. Do those three side lengths make a right triangle? Yes, they do. So yes, this is also a Pythagorean triple. There's our first example. Now, my next example, I have same concept, three different side lengths. This time we have 0.6 centimeters, 0.8 centimeters, and 1 centimeter. Do those three side lengths make a right triangle? I don't know yet. I'll have to put it into the a squared plus b squared equal to c squared. The next part, are the three numbers of Pythagorean triple? Well, I'm going to look at that one right away, and I'm going to go, I don't have to go any farther to know that those are not the Pythagorean triple. So I'm going to put no right here just for mine. And the reason I know it's not a Pythagorean triple is because this number right here is a decimal. And remember, in order to be a Pythagorean triple, it has to be a whole number. That's not a whole number, therefore I know right away, not a Pythagorean triple. But I still want to check to see, is this a right triangle? So again, I go back to the little equation, a squared plus b squared equal to c squared. If this works, or it's true, then we have a Pythagorean, or we'll have a right triangle. So now I just plug my numbers in. Again, I'm going to start with my hypotenuse, which one has to be the biggest. That's going to have to be right here. And then the other two I can put whatever, or it doesn't matter which order I put them in. So I'm going to go 0.06 squared plus 0.8 squared. Does it equal to 1? And then I do need the squared on that. Well, square this, we get 0.36. Square the 0.8, and we have 0.64. Square 1, it's still 1. Add these together, that's 1. So 1 equals 1. Therefore, yes, this does make a right triangle, or these three sides make a right triangle. I'm just going to go with yes, right triangle. But does it make a Pythagorean triple? No Pythagorean for the Pythagorean triple. And there's the second part of our Pythagorean theorem video. So remember, in this one, we, right here, we're able to determine whether it was a right triangle or not by using a squared plus b squared equal to c squared, plugging our numbers in. And then we were also able to determine if those three numbers were Pythagorean triple or not, if they satisfied a squared plus b squared equal to c squared, and they were whole numbers, Pythagorean triple. So, hope that helps out. Enjoy.